Welcome back. This episode is about red teaming LLM and agent systems. We'll walk the real attack surface, why the classic exploits work, and how a senior who finds bugs differs from a principal who builds the whole program.
Before techniques, get the framing right because interviewers listen for it. The whole field rests on one structural flaw, and if you name it early, everything else hangs off it cleanly.
Let's start with jailbreaks. Walk me through what's actually happening when a model gets talked out of its guardrails.
A jailbreak isn't magic. Safety is trained behavior layered on top of a model that wants to be helpful. So you create a context where compliance looks more aligned than refusal. Personas, hypotheticals, translation into a low resource language, or an optimized adversarial suffix all do the same thing. They shift the model out of the distribution where its safety training fired.
Now the one everyone conflates. Distinguish direct from indirect prompt injection for me cleanly.
Direct injection is the attacker typing into the prompt themselves. That's basically jailbreaking. Indirect is the dangerous one. You plant instructions and content the model will later ingest a web page, an email, a PDF, a calendar invite, and when the agent reads it, your text becomes its instructions. The victim never sees it, and you never touch the chat box.
Before we go further, where does system prompt extraction fit, and how does it connect to actual data exfiltration?
First, you coax the model into repeating its hidden instructions, sometimes directly, sometimes by asking it to summarize everything above. The prompt is rarely the prize, but it leaks tool names, endpoints, and guardrail logic. That's reconnaissance. Then comes impact, and the pattern is read then send. The agent can reach something sensitive, a document store, an inbox, a connected database, and your injected instruction tells it to package that data and push it out a channel it controls. The classic is a markdown image whose URL carries the secret in the query string, so just rendering the reply phones home. Any outbound capability, a fetch, an email, a webhook becomes an exfiltration path.
Tool and function calling is where agents get powerful. What goes wrong there, and what's the confused deputy?
A confused deputy is when a privileged component acts on an unprivileged party's behalf. The agent holds the credentials and the permissions, the attacker supplies the goal through injected data, and the agent dutifully executes. You also attack the tool arguments themselves, smuggling a path traversal or a query into a parameter the model fills in. The model is a trusted deputy being told what to do by untrusted input.
Now scale it up. What changes for multi-agent systems, and how does rag poisoning fit in?
Multi agent systems trust each other's messages, so an injection in one agent becomes an instruction the next obeys, and autonomy removes the human checkpoint so it runs many steps before anyone notices. Rag poisoning is the stored version. Write instructions into a wiki page or a ticket the system indexes, tune them to retrieve, and they fire against whoever asks a matching query, persisting across users until the corpus is cleaned.
This is the senior versus principal line. What separates finding these from leading the effort?
A senior finds the exploit and chains it, injection into tool abuse, into exfiltration, a clean end to end kill chain. A principal builds the program around that, a repeatable methodology, a threat model tied to the system's real architecture, and a way to measure how much of the attack surface you've actually covered. Senior proves a bug exists. Principal can tell you what you haven't tested yet.
How do you red team at scale? Talk about automation and frameworks.
Manual probing finds the creative bugs, but you can't ship on vibes. You run libraries of seed attacks, mutate and evolve them, and use a judge model to score whether a response was actually unsafe, then wire it into CI so a prompt or model change can't silently regress. Tools like Pirate, Garrick, and PromptFoo live here. Automation gives you breadth and repeatability. Humans give you the novel chains.
So how do you measure coverage and write findings that someone will actually fix?
Don't report a raw jailbreak count that just measures how hard you pushed. Map attempts to a taxonomy of harms and surfaces, and report which cells you exercised and which you didn't. A useful finding states the attack class, the business impact, a reliable repro, and a concrete mitigation. Then you retest after the fix. Coverage is about the surface you've explored, not the number of gotchas you collected.
What quietly marks someone as junior in an LLM red team interview?
Showing one cute jailbreak and stopping with no path to impact. attacking without a threat model so you can't say what you skipped, treating a pile of bypasses as coverage, and dropping findings with no mitigation or retest. The goal is realistic adversarial testing of a real system, not a screenshot of the model saying something it shouldn't.
If someone keeps one thing from this episode, what is it?
Every attack here comes back to one fact: the model can't tell trusted instructions from untrusted data. So the whole system around it is the target. Chain your exploits to real impact, measure coverage against a threat model, and report findings someone can fix. Next episode, we go up a level, leading offensive AI security at principal scale: the strategy, the team, and the program.